Hi scholars, so today we're completing Module 2, Lesson 11. Let's start with our learning intention. Thoughtful mathematicians solve mixed word problems involving all four operations with various metric units. So leave the extra with. So all four operations, that includes addition, subtraction, multiplication, and division. Those are the four operations in math. Addition, subtraction, multiplication, and division. So if you're ever asked which operation are you going to use to solve, that is what it means. It's not the strategy, it is the operation, meaning are you adding, subtracting, dividing, or multiplying. Let's look at our vocabulary. The metric system is a system of measurement based on tens, and there are three forms of this measurement. So we use liters to represent volume, liquid volume specifically, meters to represent length or to measure length, and grams to measure the mass of an object. So liquid volume or capacity is used for liters. Here it says cubic units, but that is for solid volume, like a box or the volume of a room. This is for liquid volume, we use liters. So like I said, liters for liquid volume, and 1 liter is equal to 1,000 milliliters. So liter is the basic unit, and milliliters is a smaller unit that can be converted between milliliters and liters. The conversion is 1 liter, like I said, equals 1,000 milliliters. So for example, 2,000 milliliters equals 2 liters. For mass, we have grams, and a benchmark we have is 1 paperclip is about 1 gram. And similar to converting between liters and milliliters, 1,000 grams equals 1 kilogram. So I'm going to solve this first word problem. Dwight purchased 48 kilograms of fertilizer for his vegetable garden. He needs 6 kilograms of fertilizer for each bed of vegetables. How many beds of vegetables can he fertilize? So I'm going to draw a tape diagram. I know that he has a total of 48 kilograms of fertilizer. And I know that he needs 6 kilograms for each bed. So I don't know how many beds, so I can't split and make my groups, but I know that each group is going to be 6 kilograms of fertilizer. So I can start by splitting this. This is 6 kilograms. So I can split again until I use up all 48 kilograms. So if I add another 6 kilograms for another bed, that would be 2 beds, and that's 12 kilograms used up so far. So let's keep going. 18 kilograms, 6 plus 6 plus 6 is 18. Keep going, another bed would be 24, 30, 36, 42, and if I add another bed, 42 plus 6 is 48, so I'm going to stop here. So I have 1, 2, 3, 4, 5, 6, 7, 8 beds, and let me just double check. 6 plus 6 is 12, 12 plus 6 is 18, 18 plus 6 is 24, 24 plus 6 is 30, 30 plus 6 is 36, 36 plus 6 is 42, and 42 plus 6 is 48. So yes, 8 beds. So my answer needs to directly answer this question. How many beds of vegetables can he fertilize? He can fertilize 8 beds of vegetables. So let's do this one together. And if you do not have the materials you need to solve with me, please pause now and gather those materials. Nancy bakes 7 cakes for the school bake sale. Each cake requires 5 milliliters of oil. How many milliliters of oil does she use? So again, let's draw our tape diagram. This time we don't know the total. That's what we're trying to figure out. But we do know our number of groups and the size of those groups. So what is the number of groups that we have? Well, we have 7 cakes, so that's 7 groups. And we know that each cake uses how much oil? 5 milliliters. So I have 7 groups of 5, or 7 times 5. So how much oil did she use? Nancy uses 35 milliliters of oil, because 7 times 5 is 35. Or 7 groups of 5 is 35. 5, 10, 15, 20, 25, 30, 35. So I want you to pause now, solve this last problem, and then press play when you're ready. Again, pause the video now, press play when you're ready. Together, a horse and its rider weigh 729 kilograms. So together, that is their total weight. The horse alone weighs 625 kilograms. How much does the rider weigh? So again, I like to use a tape diagram. You don't have to, I'm just modeling using a tape diagram. I know together their combined weight, both of them together, is 729 kilograms. I also know that the horse by himself or herself weighs 625 kilograms. So I want to find the rider, this missing part. Well, I have the part, I don't have the other part, but I know the whole. So in order to find the difference in weight between the total and this part, I can subtract. So 9 minus 5 is 4, 2 minus 2 is 0, and 7 minus 6 is 1. So 104 kilograms. The rider weighs 104 kilograms. That is my final answer. So again, I subtracted because I knew the total and I knew one of the parts. So I subtracted the part from the whole to find the other missing parts. Thank you so much for watching, and be mindful of the operation you use: addition, subtraction, multiplication, or division. Make sure that you're looking at the problem and trying to identify what operation would be best suited to solve that problem. Don't just randomly add or subtract the numbers you see, but use the information you're given to figure that out. As always, you can reach out to me on Schoology or Hangouts for any questions, or if you want a separate call to review this.